Hello, this is the next video in a playlist that I'm calling Hypothesis Testing, and this is part 3 of a little part mini-series within that larger playlist. And we're doing illustrations of a two-sided, uniformly most powerful test. And this really sums up why I chose the previous two examples in the parts 1 and 2. And I almost didn't create this video, but I think there's a lot of educational value in this video, and so that's why I created it. So let's assume we know the uniformly most powerful test for a shifted exponential, and I'm gonna pass you off to part 1. So the density for a shifted exponential is this, and we know the uniformly most powerful test for this two-sided test, which we determined was this. Okay. Now technically this should be divided by 2 in order for it to be an alpha level test. So we know this, and now we want to find the uniformly most powerful test for theta naught versus theta not equal to theta naught, where xi is a uniform density from 0 to theta. So we know this, we want to derive this. How can we do it? Using this knowledge here. And this is how we're going to do it. So the answer is, and there's, I think, 3 steps. First, we're going to transform a shifted exponential to a uniform. So let's let xi be the shifted exponential with parameters a and b. We're going to assume b is known, and of course xi is above a and goes all the way to infinity, and this is for all I. And I wrote it like this, and you'll see why in a second. A lot of times you just say xi is greater than a for all xi. But I wanted to put that infinity in there, right? We don't accept infinity. It's not like a real value, so it has to be less than that. So let's let y equal e minus x divided by b. And now let's find the density for y. So let's back solve for x. And you get x is equal to minus b log y. Now the derivative of x with respect to y is, so you get minus b 1 over y, so which is this. So now the density for y is, we use the density for x, but we plug in this value here, and then we take the absolute value of the Jacobian, which is this right here. So using this, and as a reminder, this is the density, right? So we get 1 over b, e to the minus 1 over b, and then this was x, but we plugged in this. And then we have minus b, and then times absolute value of the Jacobian. So it's just b over y. So here the b's cancel. We're left with that y, which is this one. And then when we multiply this in here, we just get log y. And here we get just a over b. Now, this ends up being the product of e to this times e to this, but e to the log is just y, so those y's cancel and we're left with just e to the ab. But if we take this downstairs, we have to change the sign of the exponent, and we get this. Now, what's the range or the of y, or the the scope of y, the domain? So here, if we plug in a here, we get minus a over b, which ends up being here. And if we plug in infinity here, then this is, limit it to minus or infinity. This goes to negative infinity, and e to the minus infinity is 0. And we go to here. Now, it turns out that these inequalities change, and I'm gonna illustrate that on the back page, why those change, and it'll be crystal clear why that's the case. I don't have enough real estate on this front page to plot the graph that I want to show you, but I'm just saying pay attention to that. So notice this is constant, right? There's in regards to y, there's no y here, right? It's constant. So that's a uniform random variable from 0 to this constant. But notice that b is known, e is known, a is not. So this is an unknown value. And let's just reparameterize. Let's just call it theta, right? So this y is uniform from 0 to theta. Now, using this critical region, remember this is our goal. Now we're going to take these critical regions and transform them using this right here, this transformation. So we plug them in. So it's e to the minus, remember it was x, but we're going to put in the C1, the first critical region, over b. So that's what this is. Reduce, reduce, reduce. But remember this we were calling theta. So we get theta naught, the nth root of 1 minus alpha. And then to convert the second critical region using the formula, the transformation, we get e to the minus 1 over b, and this would have been x, but we put in C2. And then this reduces to this, but we were calling this theta naught, and that's the nth root of alpha. Okay, so now this is the graph that I wanted to show you. So this is x, and so notice that, like, if somewhere there's a largest value, xn, and if we transform that, it gets put to this y value, and then there's more x's, and then somewhere there's a smallest x, so x1, the first order statistic, and that gets transformed to here. But notice the largest here gets transformed to the smallest here, and the smallest x gets transformed to the largest x. So in a sense, they're reversing, and that's kind of why the inequality is reversed on page 1. But notice that x1 is getting transformed to the largest. So x1 is transformed to the nth order statistic in y. So now, if you look at the second part, or part 2 of this little mini series, we get this answer. So the uniformly most powerful test is this. For this hypothesis is this function. Notice that this is the value that we transformed, the critical region. Here's the critical region. I probably should call this y, but x1 in the shifted exponential gets transformed to the nth order statistic in the exponential. And so that's where we have an x in here. So notice that on page 1, this is a test we know, and x1 is in the shifted exponential, and that gets shifted to the nth order statistic, right? So that's why it's an xn. And the same way here, xn is greater than this critical region. And then one final note is that we had to switch the inequalities. And that's because of the way that this all works. It's kind of being transformed. So don't forget to shift inequalities. And this ends up being the same exact test that we derived in part 2 of this little mini series. So anyway, I thought that was informative, that when you have you have a uniformly most powerful test, and then you take a function of it, it's a one-to-one onto function, then that uniformly most powerful test transforms, translates into that transformed variable. Anyway, so that's why I picked those 2 examples in part 1 and 2. I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.